Alright, well, a warm welcome again. So where we left off last time, we got the screen up and our Tetris piece showing up, but I actually made a little mistake. So although we changed the shape, I forgot to change the color, and to fix that, it's actually right here. So this line, what it does, it creates a rectangle which clips that larger set of tiles, and I'll just show you what the tiles look like. So yeah, there you go. So the idea is that the rectangle traverses along, and then you clip the right one. But the problem is in the code we actually just kept it as 2. To fix that, we're going to change it to color. And while we're here, actually, what I might do is actually just get rid of that, and we're going to set the color in the header file. So the first thing would be to create that here. And in the constructor, I'll just also take in a color, which means I could do something like this. So yeah, similar to before, where we are going to I think that should work. Okay, and yeah, see, we call the color, so that means in the main I'll have to do Tetramino tile, yes, so I need to put in a color, so for now I'll just put in 3. Let's see if that works. It is building, and success. Alright, see, the color changed and the shape changed as well. So before, what we did is we shut off the background. We're going to put that back on, and now we're going to move on to the next step, where we're going to move our Tetris piece based on keyboard input. And to do that, oh, there we go. To do that, the first thing we're going to do is have to head up here into our Tetramino class, and we're going to include the Q key event library. And I guess I'll make a little function here, so what should I call it? Oh yeah, I'll just call it key press event. So oopsie. Key press event. And what that's going to take is a Q key event, and that'll be, there we go. Okay, so what I'm going to do now is I'm going to just hop in here, refactor, and then add definition to our tetramino.cpp. Okay, so really what this is going to be is a bunch of if statements, right? So if we move a particular key, we're going to expect a response. So the first one I'm going to do is going to be the left arrow key. So that'll look like this. It'll take in the event key. We're going to then check if it is the same as the left arrow key, underscore left. There we go. And if that is true, we're going to take our piece here. So this setX function is inherited from the QGraphics item class, which we talked about a bit more in the last video. But basically all we're doing is we're taking our X position and we're going to move it to the left using the tile size, so tile underscore size. There you go. I'll just close that up, and while we're here, I'll just go ahead and I'll do the else if event key, similar to before, of course. So this time we're going to check for a right key. Okay, and then again we're going to set our X position. This time we're going to add. Okay, there's a few more I wanted to add in, but let's just run that to see if it works. Kind of slow to build. Anyway, alright, so as I'm hitting my right key, oh, nothing happens, and I think I know why. So when you want a particular item or a particular class to receive keyboard inputs, you have to actually set it to be focusable in the Qt framework. So let's just do that here. So it'll look like this. This set flag Q graphics item is focusable. Okay. And then this set focus. Alright, so we just set it to be the focus. So yeah, that all happens in the constructor. So, you know, we take in our tile size, we take in the color, and then it's going to draw the blocks on the screen, and then after that, it'll be focusable. So we should be able to receive those keyboard inputs. And we're going to try that again, fingers crossed. Boom! Alright, so I'm moving my right key, it moves to the right. I'm moving my left key, it moves to the left. And now I'm going to do the down key and then rotation, which is going to be the up arrow. So down here, similar to before, what we're going to do is the key up now. So I'll just do again an else if. I'll just copy. Key up. Okay, so for this one, we're not going to change the X position, we're actually going to rotate. So luckily there's a nice function called set rotation, and instead of the X position, or the X variable, we could take out the rotation. And then instead of tile size, right, it doesn't really make sense, we're going to add 90 degrees. So it'll spin 90 degrees every time we hit the up key. Finally, we're going to do the, come down here, we're going to do the down key. Qt key down. Right? Okay, and then as you can probably imagine, the rotation isn't very useful, but the set Y function would be our best bet. And here's the Y key, and then we're going to do tile size again. Right, so the idea is like we only move one grid spacing every time we press the key. So let's just give that a whirl. Okay, so yep, there we go. We're moving right, we're moving left as we could expect. I'm going to move down, and yep, we're moving down, and now up arrow. Boom! Alright, we got that nice T-spin that we all know and love. Perfect. Okay, so a few things we can just check off our list is actually the starting position. That might be one of the easier things to do. And we could do that once in our draw blocks function. So we call this function here draw blocks. We set the rotation in this line. What I'm going to do now is just set the starting position. So this set pause, right? And we're going to be looking for an X and Y. Because our grid is all based on like the pixel size, probably makes sense to just like, you know, have a factor and then add that tile size. I keep saying pixel size, I mean to say tile size. So I'm just going to try that for now. That'll be our X, and then for our Y, I think it was actually at a pretty good height, but what I'll do is I'll just go 0 times tile size. Just for now, just to see. Oh, and of course I gotta close that up. So all we're doing here is just trying to fudge it a bit to just get the tile right in the right spot at the start. Okay, so we're pretty far off. We want to move over like, I don't know, 2 more tile spacings, maybe 3. Or 2 tile spacings, and I'll shove it over a bit, like maybe 9 pixels. So I'll just do that. So instead of that, I'll do 5, and then we'll add, I don't know, maybe out here, plus 9. So yeah, very hard-coded here, but again, we're just kind of putting a shape on top of another shape, so. Okay, yeah, way better. Yeah, looks like we're pretty much bang on there. I just need to shove this thing down now, so I'll do, what I could do is add or subtract just by like, I don't know, 3 or 6 pixels, something like that. I'll just subtract 6. Okay, that's looking pretty good. That is looking pretty good. So as I move down, and then if I rotate, right, I'm still in that grid. I fit pretty nicely in that grid, so that's pretty great. Okay, and was there anything else I wanted to do? Oh yeah, so I'll just play that again. So we kind of move infinitely across, so it probably makes sense to do like our collision check with the border here. So we're looking to stop right at that gold border, and again over here right at that gold border. So that's pretty easy. We're just going to make a new function in this class again. We're going to call it collision check. So this time, instead of it being void, we're going to do bool. Jean check. And I'll just comment here. Functions. Okay. So again, I'm going to highlight this whole thing. I'm going to refactor and add the definition to our Tetramino class. So for now, just for the purpose of this video, I just want it to kind of spit out the message first. And to do that, there's a little library called qdebug. So I'm just going to add it here. So in our header file, include qdebug. Sweet. And basically, I just want it to yell. So qdebug is basically just like the cout of the Qt framework. So it'll just spit out messages whenever you have a condition. Okay, so I'll just tab over here. Basically, you know, we want to create a border. So I'm going to say when our scene bounding rectangle. So the bounding rect is basically just the border of our graphics item. So in this case, it'll be the Tetris piece. If it's one of the square pieces, then you know it's going to be the square. It'll be the border of the square. But if it's like a T, then it'll be the edge of the T on the left side or the right side. So yeah. So if we get our leftmost point, and if that happens to be greater than, let's say 0, right? Then we're going to say that that's a collision. We'll play around with it a bit once we actually get it on the screen. If the right is, I don't know, less than, if it's less than 12 times our tile size, then we want it to do something. And then while we're here, I guess I'll just do the bottom. So similar to before, again, scene bounding rectangle has a bottom, which is pretty handy. And this will be, we're hoping it'll be less than, I don't know, 25 times. Okay. And if any of those conditions are met, I'll just close off that. Oh, tile size. Then we're going to return true. And then if not, then we'll I guess we're going to q debug, right, just to spit out our message. Collision. And then we're going to return false. I guess I gotta do a little semicolon there. Okay, so the thing is, this function actually doesn't get called, so I'll do that right here. So every time we hit a key, we're going to do a collision check. Doesn't really need to do anything beyond that. For now, anyway. Alrighty, let's give this a whirl. Oh, I got a issue. Unexpected expression at 74. So feel like I didn't close that right. Oh yeah. Okay, let's give that a whirl. Oh. Let's give that a whirl. Okay, so I'm expecting to see, oh, and it says it has a collision already, so every time I collide, that's wrong. Let's try it here. So if it's, oh yeah, that's right, because if it's not, okay, this makes more sense. Yeah, the whole point of that was if it's like a not condition, I'm saying that there's no collision, so confused myself there. Alright, so no issues, and then I have a collision. So it looks like I'm a little off on my border there. If I go this way, all the way to the right, I have a collision. So, and then if I go down, keep going down, I have no, okay, at the bottom there I have a collision, so I'm way off. So I'll just talk a little bit about that scene bounding rectangle. So the idea is that, you know, it has a rectangle that goes around all of the graphics items. So it'll just be like this. The idea is like on our right, it'll be this kind of value here. If that value, you know, exceeds, then we have a collision. So it looks like for our down condition, we're off by like, I don't know, 1, 2, 3, 4, 5. What we'll do is actually we'll do that, and then I think what I had before was actually pretty good. I can't even remember. Was I think by 2 maybe? Let's try that. Okay, so I want it to collide once it touches the goal. Then let's see. Boom, alright, success. And once again, pretty good up until, yes, alright, and then the last one is the bottom border. Yes, alright, perfect. Okay, and no collision there, so I did the up arrow, and we're all good. If I do the up arrow again, we're all good, but if I move down, collision. And then up arrow, collision, collision, collision. So, there we go. Alright, I guess I'll stop the video for now. Thanks for watching. In the next video we're going to fix those collisions, so it'll be like a real border. It'll restrict the key movement, and then we'll also like include the timer, because in Tetris, you know, the piece falls at a natural rate, independent of the keys you press. So we'll add that in as well. Alright, until then, take care.